Adaptive icons are Google's way of making app icons look clean, consistent, and polished across all devices. Think of them as your app's chameleon-like feature. They adapt their shape to match the design preferences of the device. Design your adaptive icon at 108 by 108 dp, with pixel dimensions varying based on screen density. But the masking size is only 72 by 72 dp. Keyline shapes are predefined geometric guides that help designers ensure consistent proportions and visual balance. Think of them as design blueprint. The first keyline shape are two concentric circles of 52 and 36 dp respectively. The next keyline shape is a square of side 44 dp. And lastly, we have two rectangles of given sizes on screen. Built with two layers, a foreground, your logo, and a background, solid or gradient. They create depth and support interactive animations on some devices. Plus, Android applies a masking system to ensure all icons maintain a uniform look. Let's see how you can add your own app icon. We will start by creating a new branch and then navigate to the resource folder in your project and create a new image asset. Make sure you have your app icon ready in SVG or PNG format. While PNG works, I highly recommend using an SVG file. It's scalable, lightweight. In the next window, select the folder icon and import your SVG file. Once imported, you'll see all the masked icons generated for different shapes. But we're not done yet. Let's clean it up. Switch to the Background Layer tab and set the background color to match your app's theme. For this example, we'll keep it white for a clean, minimal look. If your logo is spilling out of the mask area, use the scaling option to resize it. Adjust the scale to 49% to bring it safely within the masked area. Once the icon is added, open the IC Launcher Image option to validate how your app icon looks across different sizes and shapes. This step helps ensure it appears clean and well-proportioned on all devices. Quickly commit these changes to your branch to save your work. Well done! You've successfully learned the concepts of adaptive icons and how to add them to your app. There is a lot to come, and so continue watching. If you are liking the video, please hit the like button and subscribe to the channel. We'll now dive into setting up a design system for your app. As always, create a new branch in your version control system to keep your work organized. Right-click in your project and select New Module. In the next window, choose Android Library. Set the module name as Design System. Update the package name as shown on the screen. Once done, click Finish to generate the module. After the module is created, make sure to add it to Git so your changes are tracked. You'll observe that the newly created Design System module has been automatically registered in the settings.gradle.kts file. This ensures the module is properly included in your project structure. Head to your libs.versions.toml file and add the versions for the following. AppCompat, for backward compatibility support. UI tooling, for UI inspection and previewing. Lottie Compose, to include Lottie animations in your Compose components. Also, make sure to add the group name for these dependencies in the library block to organize them properly. Since we created the module as an Android library, it has already been added automatically in the project structure. Navigate to the build.gradle.kts file of the Design System module and configure the Compose plugin. Next, enable Compose build features. In the dependencies block, include the following. Compose BOM platform. Material 3. Lottie Compose. UI tooling, to support previewing and debugging UI. Next, the goal is to move all theming-related files into the Design System module, keeping everything neat and focused. Take the theme folder from the app module and move it into the Design System module. When you do this, a dialog will pop up asking you to confirm the refactoring. Go ahead and hit Continue. No second thoughts. Why are we doing this? Because we want the design system to focus on just one thing, providing themes and reusable components. No multitasking for our modules. Now, your main activity might throw a tantrum because it can't find the Cachewise theme anymore. Don't panic. This is expected. Let's fix it. Head over to your settings.gradle.kts file and enable Type Safe Project Accessor. This lets you refer to modules like dependencies. Now, in the app modules build.gradle.kts file, add the Design System module as a dependency. Sync your changes, and voila! Problem solved. Main activity is now happy and can find Cachewise theme again. Before we dive into building components, let's take care of a quick setup. Don't worry, It's a simple process. Add a new resource directory. By right-click on your module, select New and then Android Resource Directory. In the pop-up, set the resource type to font. This tells Android Studio that this folder will store all your custom fonts. Now, just drag and drop your font files into this newly created font folder. Pro tip: both .oth and .ttf file formats are supported, so feel free to use whichever works best for your design. Alright, now that we've added fonts, it's time to put them to use and refine our app's typography and color scheme. Let's break it down step by step. We'll start by creating a font family variable in the type.kt file. Add each font along with its corresponding font weight. In Jetpack Compose, typography defines the styling and appearance of text in your app's UI. We'll start by creating a display medium style and specifying font weight for how thick or thin the text looks, font size for the size of the text in SP, line height for the vertical space between lines, letter spacing for the spacing between characters. Next, we'll do the same for other styles like display small, title medium, label small, and label large. You might be wondering, are these sizes just random guesses? Nope, there's a method to the madness. Head over to m3.material.io and check out the typography token section. For example, if we expand the label styles and look at label small, the font weight is medium, so we use font weight medium. The font size is 11 points, which we translate to 11 SP. The line height is 16 points. The letter spacing is 0.5 SP. Following these specs ensures your typography is consistent with Material Design 3 standards. Now let's spice things up by replacing the default colors with your own custom palette. Open the color.kt file. Delete the existing colors, they've served their purpose. Add your own color values, using hex codes that match your app's theme. After updating the colors, you'll notice errors in the themes class because the existing color references no longer exist. Don't sweat it. Just replace the broken references with the new colors you've added, and everything will be back to normal. Now it's time to make your app's layout consistent by creating a dimension file. Here's how we'll do it. In this file, we'll define all the dimensions you'll need for your app. Pro tip: stick to even numbers for dimensions. It just makes layouts look cleaner and more balanced. Next, we'll create a local dimension variable, which is a composition local for a dimension object. Wait, what's a composition local? Think of a composition local as a magic way to share data across your app's UI without needing to pass it down explicitly through every composable. Once you register a value using a composition local provider, it can be accessed anywhere in the app using .current. No more repetitive parameter passing. Let's see an example of using a local theme color. Let's say you've created a local theme color for a gray color. Once it's registered with a composition local provider, you can use it in any composable. Simple, right? It's like having a shared stash of values your app can pull from whenever needed. A few things to keep in mind. 1. Composition locals are scoped, meaning their values are only available within the part of the UI tree where they are provided. 2. If no value is explicitly provided, the default value, defined in your dimension file, will be used. This way, your app always has fallback values, ensuring nothing breaks unexpectedly. Alright, let's keep the momentum going. Next up, we'll create a shapes data class where we'll predefine all the different shapes your app might use. And yes, we'll use composition local for this too. Once the shapes are set up, we'll plug them into your app's theme, so they're easily accessible throughout your UI. And just like that, your app will have a consistency. Thanks for sticking around. Let's recap what we've learned so far. We've covered a lot of ground, from creating a module to adding custom fonts. We covered typography the Material 3 way. You replace default colors with your own palette. We unlock the magic of composition locals. Before we dive into the code, let's first understand what a span is. Think of it as a way to style certain parts of a text to make them stand out from the rest. You can use spans to highlight words, change colors, add bold text, or even make parts of the text clickable. In Jetpack Compose, we use annotated string to create text with multiple styles, and span styles to style specific ranges of text within an annotated string. Let's make this clearer with an example. We'll start by building an annotated string using buildAnnotedString. Within this, we use the withStyle function to style parts of the text. For instance, We can highlight a word by making it red and bold. You can see some common use case of spans on the screen. Let's move to building our span framework. Let's start by creating a sealed class called spanType. A sealed class lets us define a restricted hierarchy of types, and all its subclasses are known at compile time. If you're unsure what a sealed class is, let us know in the comments. Maybe we'll make a quick video on it. We've defined 3 types of spans. 1. URL span, 4 links. 2. Click span, 4 clickable text. 3. Heading span, 4 styling headings. Next, we'll create a helper function that takes normal text and a list of span type objects and builds an annotated string based on the spans. Start by defining a current index equals 0. For each span, find its index in the full text. Check if the span exists in the text. For a URL span, use withStyle to add a hyperlink. For a click span, use a clickable annotation. Next, let's do optimization using scope functions. We can clean up this function further by using scope functions like with or apply to reduce redundancy. For example, instead of calling withStyle multiple times inside the when block, we can move it outside the when block and just define the style conditionally. Here's the final version with optimizations. Alright, let's take your app's text styling to the next level. In this section, we'll create custom text types, build reusable text components, and even set up our own preview templates for better visualization. Let's break it down step by step. First, we'll define an enum class to list all the different types of text styles we want to support in the app, like headings, body text, captions. This keeps things organized. We'll create helper functions. getColors extension function, a composable function that matches each text type to the appropriate color from the material theme. getStyles extension function, another function that returns the typography for each text type, pulling from the typography system we set up earlier. Now it's time to build the main attraction, a custom composable text component called CWText. It will take 3 parameters: the text to display, the text type, and text alignment. While it's common to include a modifier parameter in composables for flexibility, we'll keep this one simple and easy to use. For the style and color, we'll use the helper functions we just created to automatically apply the correct settings. Next, we'll create a variation of CWText that supports annotated strings instead of regular text. This allows you to include spans, links, or other rich text styles. We'll call CWText with different parameters to see how each text type looks. Visualizing your components is key. So let's add previews for our CWText composables. Use the app preview annotation to see how your text looks in real time, without needing to run the app. Wrap your text components in a column to display them stacked vertically in the preview. After building and refreshing, you'll be able to see the preview instantly. While Jetpack Compose provides powerful preview templates like preview screen sizes and font scales, sometimes you need something tailored to your needs. We'll create a custom annotation class called CW Preview. This combines font scaling, dark light themes, and device settings into one template. We'll add annotations like at retention, binary, and at target to scope this to functions or other annotation classes. By replacing the regular at preview annotation with at CW Preview, you'll have a cleaner and more personalized preview setup. Wait, something's off. Even though we set the UI mode as night in our preview, it's still showing the light theme. Here's the fix. We'll create a preview surface composable to wrap our previews. The surface composable automatically applies the correct content color for all its child composables based on the theme. Once we replace the column with preview surface, voila, you'll see both dark theme and light theme previews side by side. We could just use Jetpack Compose built-in text composable directly, but when you're working in a big team or organization, it's important to create predefined, reusable APIs. This way, your components are simple, consistent, and easy for everyone on the team. So, let's do the same for buttons, just like we did for text. We'll start by creating an enum class called ButtonType to define the 3 types of buttons our app will support. Filled tonal button for a button with a primary color background. Secondary button, a simple, text-only button with no background. Elevated button, for a button with a subtle elevation for depth. Just like we did for text, we'll create some helper functions to handle styles, colors, and other button properties based on the button type. An extension function that returns the correct text style for each button type. Another extension function to set the elevation for each button type. GetButtonColor function determines the button's background. For buttons, width is often a question of consistency. If a button needs to take up the full width of the screen, we'll use Fill Max Width. Otherwise, we'll give it a fixed width of 180 dp. Regardless of the width, the height will always remain 56 dp. Now it's time to bring everything together. We'll create a custom composable CW button. We use parameters. Text for the button. An optional icon. The button type to determine styles. A lambda on-click function for handling user actions. Inside the button, we'll use a row with centered horizontal alignment to display the icon, if available, alongside the text. For the text, we'll reuse the CW text composable we built earlier to keep things consistent. To add some variety, we'll create a specialized Google button composable. This button will take two lambda functions, on success and on failure, for handling different outcomes. We'll implement the actual functionality for this in a future video, but for now, the basic structure is ready. Finally, let's see if everything works as expected. We'll create a button preview composable to display all the different button types. Next, let's bring your app to life with some Lottie animations. These are great for adding those fun, engaging animations. We'll create a Lottie composable that can load Lottie animation files directly from a URL. This makes it super flexible and reusable, as you can easily swap out animations without touching your code. We use Remember Lottie Composition to create and cache the Lottie composition object. This ensures the animation is loaded and remembered efficiently without reloading every time the composable recomposes. To play the animation, we use Animate Lottie Composition as state. This manages the animation's playback and state seamlessly. Let's create a smooth and visually appealing pager for your onboarding screen. It's a must-have to guide users through those initial steps with style. We'll start by creating a composable that includes the essentials. Page count. How many pages your onboarding flow will have. Pager state. This will control the pager and let us observe properties like the current page. Composable lambda. A flexible way to pass the content of each page dynamically. We'll use a column with its horizontal alignment set to center. Inside this column, we'll add a horizontal pager, which will use the pager state to control and monitor paging. Take up the remaining space with modifier.weight. Indicators give users a clear sense of where they are in the onboarding flow, so let's create them. We'll build a row of indicators that 1. Track the current page. Use the current page index to highlight the active dot. 2. Know the total page count, so we can draw the correct number of indicators. Based on the total page count, we will create the required number of indicators using the repeat function. Style each indicator's shape, color, and size based on whether it's the current page or not. To draw the indicator itself, we'll use a box and clip it to the desired shape. Let's quickly preview our ViewPager and see it in action on a device. Once that's done, we'll move on to building an error banner, a red banner that pops up to show error messages whenever something goes wrong. It's a simple yet effective way to communicate issues to users, and it will automatically disappear after a given time. Let's dive in. We will create screen contain. This composable will accept a boolean to determine whether the banner is visible, a string for the error message, a lambda composable to wrap the actual screen. We'll use remember to save the state of the boolean show error. This ensures the state is preserved across recompositions. To manage the visibility of the banner, we'll use a LaunchedEffect. A LaunchedEffect is a composable that runs a block of code whenever a key parameter changes. It cancels the previous coroutine if it's still running when the key changes. It's lifecycle aware, which means the coroutine is cancelled automatically when the composable leaves the composition, preventing memory leaks. Let's see a code examples. If the key is unit, the block only runs once because unit doesn't change. If the key is dynamic, example, user ID, the block will rerun every time the key changes. We'll use the show error boolean as the key. This means the launched effect will trigger every time show error changes, ensuring the banner appears when needed and disappears after the timer expires. For the error text, we'll simply use a text composable to display the message. Yes, we should have used the reusable CW text composable here, but I'll update this in a future commit. No one's perfect, right? To make the banner appear and disappear smoothly, we'll use animated visibility. Define custom enter and exit animations. For enter transitions, you can use 1. Fade, scale, slide, expand. For exit transitions, you can use fade, scale, slide, shrink. And that's a wrap. We've covered so much in this video, from building reusable components like the ViewPager and error banner to adding smooth animations and state management with LaunchedEffect. Thank you so much for watching and sticking with us till the end. If you found this video helpful, don't forget to like, subscribe, and turn on the notification bell so you don't miss the next one. See you in the next video. Happy coding!